Let's have a look at solving simultaneous equations, but this time we're going to be using the elimination method. In earlier videos we had used the substitution method, where we substituted one equation into the other. This time we're going to try and eliminate one of the variables, get rid of the x or get rid of the y. Let's have a look at our two equations and label them equation 1, equation 2. And what I'm going to do in this method is combine my two equations. I'm going to get equation 1 and I'm going to add it to equation 2. So I'm just going to add my like terms together. So x plus 3x gives me 4x. Y, take away y. Well, they've cancelled one another out, which is what we wanted. We wanted to eliminate a variable. Then I've got 4 plus 8, which is 12. Now doing some algebra, divide by the 4. X is 12 divided by 4, which is 3. I know one of my values in my coordinate. I've now got to find the second one. And as we have done in earlier methods, I'm going to substitute x equals 3 into one of my equations. Doesn't matter which one. I'm going to choose 1 because it looks simpler. I've only got one x and one y. So x plus y equals 4 is the equation. I now have 3 plus y equals 4 after I substitute that x in. I can use some common sense here and say, well, y must be 1 because 3 plus 1 is 4. Or if you want to go through the algebraic process, take 3 from both sides. Y is 4 take 3, which is 1. So my coordinate, my point of intersection is 3, 1. Let's have a look at another example. Equation 1, equation 2. Look at my y's. I've got a y here and a y there. One's a plus, one's a minus. They're going to cancel one another out. So let's do equation 1 plus equation 2. 3x plus 2x is 5x. Y, take away y. I've got one y, I'm taking one away, it's gone. Equals minus 2 plus minus 8 is minus 10. Get rid of the 5. X is minus 2. Go back and find the y value. Substitute x equals minus 2 into one of the equations. Doesn't matter. I might choose equation 1 just to try and avoid this minus, because if you know that you mess up with minuses a lot, avoid them where you can. So let's go into equation 1. 3 x's, well, x is minus 2, plus y is minus 2, minus 6 plus y is minus 2. Get rid of this minus 6 by adding it to both sides. Y equals minus 2 plus 6 is 4. So my point of intersection is minus 2, 4. Here's another example. Equation 1, equation 2. Now in the first two examples I have done equation 1 plus equation 2. But we'll have a look what happens here if I do that. 4 plus 7 is 11x. Y plus y is 2y. 6 plus 9 is 15. Keeping in mind what this method is called, which is the elimination method, I haven't actually eliminated anything. I've still got an x and I've still got a y. So this process of just adding them together every time is not always going to work. Let's try something else. Instead of adding them together, if I was to take them away from one another, y take away y, that would eliminate this variable. I can take these away, I can take these away, and that would work. But I'm going to change it up even more because I've noticed that the numbers in equation 2 are actually bigger than the ones in equation 1. So it would make more sense if I went equation 2, take away equation 1. And look what happens now. 7x take away 4x is 3x. Y take away y, that's eliminated. 9 take away 6 is 3. Then your algebra backtracking, 3 divided by 3 is 1. Substitute x equals 1 into one of your equations. Let's go into number 2. 7 x's, x is only 1, plus y is 9. 7 plus y is 9. Take my 7 away, y is 2. So my coordinate is 1, 2. So from this example, what we can see is we can really manipulate this line here to be whatever we want to make one of the variables disappear. I can take them away from one another as we did here, or over in these other pages I added them. Whatever it takes to make one of these variables disappear. Let's have a look at this one here. This is a little bit different again. Equation 1, equation 2. Now have a look what's different here. In all of these ones that we've done prior, I had a matching coefficient. So I had a 1y and a minus 1y. They cancelled one another out. A 1y and a minus 1y cancelled one another out. A 1y and a 1y, when I took them away, they cancelled one another out. I had matching coefficients on one of the variables. But here I don't. Here I've got a 1x and a 2x. So if I added these together or subtracted them, I'm not going to eliminate one of the variables. Here I've got a 1y and a 3y. They don't match. If I add or subtract those equations, they're not going to disappear. So we're going to be a little bit sneaky again. Something else to consider. I need one of these coefficients to match one of these. I don't care whether you eliminate the x or the y, but I'm going to need one of these to match. So here I've got a 2x, here I've got a 1x. If I was to get equation 1 and double the whole thing, so what I'm doing is getting this whole equation and doubling it. I'm going to have 2x take 2y equals minus 2. Let's call that one now equation 3. Lining equation 2 back up under it. You can see now if I did equation 3, took away equation 2, our coefficients, because they match, are going to cancel one another out. So let's go. 3, take away 2, 2x, take away 2x is gone. Minus 2x, take away, now be careful, be careful, be careful. I'm taking this whole thing away, so be careful of the signs. Let's go back to the start. 2x, take away 2x is gone. Minus 2x, take away 3 is going to give me minus 5y. Minus 2y, take away 3y is minus 5y. Minus 2, take away 13 is going to be minus 15. Then I'm going to divide by minus 5. Y is going to be 3. Now what's left to do is what you've done in every single problem that you've done of simultaneous equations. You need to find the other one. So I'm going to sub y equals 3 into one of these equations, probably easiest to go into 1. You'd go into 1 or 2 or even 3 if you wanted to. So equation 1, let's just write it out. It looks like that, and I'm subbing y equals 3. X take 3 is minus 1. Add my 3 to both sides. X is 2. So my coordinate x, y, 2, 3 is my solution.